So yeah, as Max said, I'm going to talk about our new API sync connector. So let me start off by introducing myself. So I'm John, and I'm a software engineer at Yelp. If you've never heard of Yelp before, Yelp is a place where users can connect with great local businesses. So users can leave reviews for businesses and then find other businesses and see what other users think. So at Yelp, I'm on the connectors team. So my team is an infrastructure team that builds tools to connect our Kafka infrastructure to various data stores. So I'm here to talk about our newest connector, the API sync connector. So what exactly is an API sync connector? Well, let me break it down. So a connector is just something that we have that moves data between Kafka and someplace else. Sync is referring to the direction of this move. So it's moving data from Kafka to a data store. Then in the name, we use API to refer to external data stores. So something that we have less control over than like MySQL. So like an example of one of those data stores would be Salesforce. But as I mentioned, we're an infrastructure team. So we're not just building a tool to move this data. We're building a tool to empower other developers in the company to build their own connections to move data. So that's actually one of the reasons why we went with Beam for this solution. Because Beam allows the other developers at our company who are used to working in Python to use the language and libraries they're familiar with. So this sounds nice enough, but where's the challenge here? Well, the root of the challenge is that basically the structure of our data in Kafka doesn't match the structure that the API expects. And since this is an external API, we don't have a lot of room to change it. So developers who want to move data to these kind of data stores face three common challenges. First, they need to transform data. Then they need to drop updates that don't really matter. And then they have to order data to make dependencies work. So I'll get into a little bit more about each of those challenges. Then I'll also cover how we solve them in Beam. And then I'll talk about how we make these solutions into generic infrastructure that developers across the company can use without having to know a whole lot about Beam. So before we dive right in, it's worth it to talk about a little bit about some example data that we're going to use throughout these challenges. So real quick, you can just see that in Kafka, we have a stream of businesses and a stream of reviews. So the businesses stream would contain updates about various businesses. Then the review stream contains updates about reviews. So if a user writes a review or edits their review, we'd get a review message in this stream. Then we need to move this data to our data store. So the first challenge is transforming the data. Basically, the data formats don't always match. So here we can see, for example, that our reviews in Kafka on the left have this review text field that we don't actually need in our data store. So the developers who are removing this data want to remove that field. So this is simple enough to do in Beam. You can just write your little transformer that inherits from doFun, and then you can define a process method, which removes the field from the message and then yields the message onto the next step. But although this seems really simple, it actually contains a few things that are pretty specific to Beam. So first off, you have a doFun. If you're a developer who's not familiar with Beam, maybe you don't know what this is. Then there's this process method. Like, what does a process method do? And then you have to yield the message back, which maybe seems a little strange. So what we want to do is we want to take this and we want to simplify it. So developers who have never worked with Beam before don't have to learn about Beam in order to just remove the text field from a message. So we turn this into a generic interface. So we define this base transformer class, which defines the process method. And it calls just a simple transform method. And all the transform method has to do is actually change the payload. So if you were a developer who wanted to write a transformer to remove the text field from a message, all you'd have to do is inherit from this class and define a transform method. You don't have to know about how Beam works internally. And maybe this seems like a bit of a trivial example. Like writing a transformation operator isn't very hard. But I think you'll see when we get to the other challenges that maybe this does actually improve the lives of other developers. So our next challenge is that often developers need to drop updates that aren't significant. So now that we've taken these reviews and we've removed the text field from them, you can see that we have two review messages which are basically identical because nothing actually changes when the second review update comes through the pipeline. So what we want to do is we want to turn these two messages into one message. So we're not sending duplicate data to our data store. Maybe this doesn't seem super important, but we actually get a huge efficiency gain when we do this, especially in cases where the data store we're sending this data to charges us by how much data we send to it. So let me walk you through how we do this in Beam. So basically, when we get data into our job that uploads reviews to the data store, the first time we see a message for a specific primary key, we take it and we store it in what we call a previous version state. So this is just a combining value state that stores the value of each message keyed by its primary key. So every time a message passes through, we update this state. Then when we see another message for the same primary key, we can fetch the previous value from this previous version state, and we can run it through what we call a threshold function. The threshold function's job is just to look at the old version of the message and the new version and decide if the change is significant. So if the threshold function says the change doesn't matter, we can just drop the message and not worry about it. But if the change does matter, then we want to keep the message, update the previous version state with its new value, and then send it on to the upload step. So hopefully, if you're familiar with Beam, this makes sense. But to developers who aren't familiar with Beam, this is actually getting pretty complicated, because now we're introducing state on top of the things you already had to learn. So we want to simplify this down into an interface. So like we do for transformers, we can define a base thresholder class. And now, if you're a developer who wants to write a thresholder to only pass through changes where the rating changes, all you have to do is define this threshold function. So this solves another problem that developers face. But there's one last problem I want to talk to you about, and that's ordering data dependencies. So the short version of this is that in Kafka, we have reviews and businesses in separate streams. And they exist in this ideal world where they don't know anything about each other. But when we upload them to our data store, the data stores we upload to often enforce strict foreign key requirements. So we have to upload reviews, which we refer to as child objects, before businesses, which are parent objects. And if we try and upload a review before its parent business is there, we get an error and it won't let us. So we have to order these. So let me walk you through how we do that in Beam. So first off, we need information about which parents have been uploaded. So doing this is easy enough. We just take our uploader from the job that uploads businesses, and every time it performs an upload, we send some information about that upload to what we call a resolutions topic. So this is just a regular Kafka topic that contains data about the uploads. So you would say for a business with key 1, we uploaded it. Then we can use this resolutions topic as a source into our reviews job. So every time something appears in this resolutions topic, we read it in the reviews job, and we send it to what we call a parent status state. So this is just a combining value state that keeps track of, for each parent, whether it was uploaded, keyed by parent ID. So now, when reviews come through this pipeline, we can check whether this review has a parent that's been uploaded. So if it does, then we know that we're safe to upload the review and we can send it on to the uploader. But if there is no parent for this review, then what we need to do is we need to take this review and hold it until the parent arrives. So we send it to what we call a held child state. So that's just a bag state that's keyed by the parent ID that the child belongs to. But of course, we can't leave these children in this state forever. So when we eventually do see a resolution from their parent, we have to check whether any children are waiting on this parent. And then if there are, we can pull them out of the state and we can send them on to the uploader. So in this way, we can ensure that parents are always uploaded first and then their children get uploaded. And hopefully you can see that this is a pretty complex process. So developers who are just trying to move their data to a data store really don't need to learn all of this complexity. We can simplify this down into a really simple interface that they can use. So if you want to upload reviews in businesses, all you have to know is that businesses have to be uploaded before their reviews. So the interface we make for this looks sort of like this. So we have this resolver, which inherits from our base dependency resolver. And all developers have to specify is the name of the parent object and the foreign key that the children use. So hopefully this is a lot easier than building that whole graph every time you need to perform this operation. So now that you've seen how we make transformers, thresholders, and dependency resolvers to let developers do these complex operations easily, let's talk about how we actually turn this into a pipeline. Because even if you can make these steps, there's still some details about Beam you have to know just to chain them together. And ideally, we don't want other developers to have to think about that. So what we do is we define this YAML interface, where developers can configure these steps all from a YAML file. Then our API sync connector will turn this configuration into a pipeline. So you can see here that we specify each step of this pipeline. So for instance, the drop field transformer we specify here is just a transformer that will drop the field you specify. So a developer who wants to, for instance, drop the rating from a review instead of the text could just configure this with a field rating. So they don't have to actually know much about how Beam works. And in some cases, if they're using a transformer that we've already built, they don't even have to write any code at all. So we think this really empowers developers to move data efficiently without having to learn a whole lot before they can do so. So we're pretty excited about this, but what's next? So first off, we want to expand our library of pre-built transformers and thresholders so that there are even more things that developers can do without having to learn much about Beam or write any code at all even. So for instance, we could have a transformer that drops a field, for example. And all you'd have to do if you want that in your pipeline is configure it in YAML and specify the field. We're also looking to move more types of data to our first data store, which is Salesforce. So currently, we're only moving a couple types of data, but we hope to eventually port all of our various data to this pipeline. Then longer term, we want to expand this to other data stores besides Salesforce as well. So for example, something like Braze or Oracle. So hopefully you can see why we're really excited about the future of this system. Thanks for listening.
All right, John. Thank you very much for the talk. All right, John. Thank you very much for the talk. We do have some questions. If you want to answer them, there's one from Slack, and it is, how does the API sync connector manage API quotas? Does it hold the API requests until the API quota resets, or does it throw an error?
Yeah, so one step I don't talk about very much is our uploaders. So we actually handled this in our uploader code where it rate limits itself. So we can make it aware of whatever quota the API has, and then it'll automatically hold upload requests until it wouldn't exceed the quota.
All right, that makes sense. And there's another question. Is it possible to plug in custom threshold functions in with using this YAML definition, or is it, do you plan to add such functionality?
Yeah, so we don't really support defining functions from the YAML. For that, we would want developers to write their own class that inherits from the base thresholder. But you can write a class that takes options from the YAML. So if you wanted to write a thresholder that did something like only send rating changes if the rating change is greater than 1, you could like write a thresholder that takes like an option where the option is how much did the rating change. So then you could specify 1, and then it could like do that logic internally, but you could still like configure how it works from the YAML.
Cool. And another question here. On what runner are you executing this?
Yeah, so we actually use the Flink runner at Yelp pretty much exclusively, but we're not like necessarily tied to that.
Right, that's one of the advantages of Beam.
Exactly.
So I see there's another question coming. Somebody's typing in Slack. Maybe we will have time to post that one. If not, then okay. I think these were good questions, and we can conclude and you can still answer questions in the Slack if there are any more. Thank you very much, John.
Thanks.
Great talk.